Yes, it's for Liberty Science Center. This is time for Sub-Zero, our demonstration of the states matter over here on the side of Governor's Hall. Everyone is welcome, and all of you are most welcome. Delighted to have you here today. My name is, I'm one of the science educators here at Liberty Science Center. You guys been having fun here today? Good, I'm glad to hear that. Are you learning something? Good, I'm glad to hear that too. Because that's what we try to do here at Liberty Science Center. Have a place that's fun to visit and where you can learn some science. And I hope that's exactly what we're going to do right now. Have some fun and learn some science. And the science we're going to learn about is something called the states of matter. Anybody know what that word matter means when scientists use it? Anybody know what matter is? Any ideas? Adults can answer too.
He might know.
What is it? You're sorry about something. Yeah, what's the matter? Yeah, that's a good use of the word matter. But when scientists use matter, they're just using a very fancy word for stuff. That's all it is stuff. The official definition: anything that takes up space and has mass, has substance to it, bulk. Do you guys take up some space? Yeah. Do you have mass? Do you weigh something? When you get on a scale, do the numbers change? Yes? My case too much? That's because you and I are made out of stuff. We're made out of matter. And so is this table up here, and so are the orange cones I hope you'll stay behind, and so is the air that's all around us. There's all kinds of stuff. Anything you can taste, touch, smell, or feel is likely to be matter. Now, matter comes in different forms. That's what we mean by states of matter. Anybody know any of the states of matter? Can anybody give me any of them? Give me one of them. Solid, that's a great one. Anybody know another one? Liquid. Anybody know another one? Gas. Anybody know another one? Pollution. Well, it begins with a P. I was thinking of plasma, but you're thinking. That's very good. Solid, liquid, gas, and plasma. Most states of matter. There are other ones, but you only see them in the laboratory, so we're not going to worry about them. Now, if matter comes in these different forms, how does it change from one form to another? Let's all think about water. What do we call water when it's a solid? What do we call it? What do we call it? Anybody? Ice, right. Let's think about an ice cube. It's a solid. You can melt that ice cube. You can turn it liquid. What do you have to put into that ice cube? What do you have to do to that ice cube to get it to turn to a liquid? Put it with some hot stuff. Perfect answer. Put some heat into it. Put energy. You know what's going on? Little bits of matter inside that ice cube. As you put more heat, more energy, they start to wiggle around more. And they get more and more energetic until eventually they've got enough energy that they are a liquid and you can pour the water. Now, suppose we wanted to turn that liquid water into a gas. We wanted to boil that water. Think about dinner. What do you have to do to get the water boiling to make dinner? What do you have to put into it? Some more heat. Yeah, you gotta heat it up. And those little bits of water get even more energetic and they break apart and they start flying around the room like a gas, bumping you and everything else. Yeah. Now, what if we wanted to turn that gas into a plasma? What do you think we have to put in? There's a theme here, guys. What do you think we have to put into a gas to turn it into a plasma? Any ideas? Who said it? More heat. And those little bits of matter start to rip themselves apart, and some of them start to glow. I can show you plasma. This is a plasma globe. It's got a little bit of gas inside. And when I turn it on and heat it up, it starts to glow. But you know what? You've all seen plasmas before. How many people here have ever seen the flame on a candle? Maybe on a birthday cake? Yeah? That little flame is a plasma. And what's inside a fluorescent light bulb that makes it glow? That's a plasma. Now, I don't want anybody ever doing this. Don't ever look directly at the sun because it can hurt your eyes. But you know what the sun looks like, right? Great big round ball. It's a big round ball. Yeah. It's a star. And because it's a star, it's a big ball of plasma. That's why it's glowing. That's why it's giving off heat. In fact, most of the visible matter in the entire universe is in the state of plasma because it's in the stars. So, is there anybody here who would like to come up and touch my plasma ball? Would you like to do that, young lady? Come here. Why don't you stand right here? What is your name? Mahika. I want you to take one finger and touch the plasma ball with it. Go. Touch 2 fingers. Put your whole hand on it. And you see what's going on? Let's come over here. Yeah, that plasma likes you. And that's because you conduct electricity, so when you get close, the plasma tries to come over here and flow through you. Very good. Let's give her a big round of applause. Great thing to do. Thank you. Go back. So, we can go the other way, too. What if we got a plasma and we're glowing up here, but we want to quench it. We want to turn it back into a gas. What do you think we have to do to that to get it to turn back into a gas? Any ideas? Take the heat out, take the energy out, cool it down. And you cool it down and it turns back into a gas. And if we wanted that gas to condense, turn into a liquid, what do you think we'd have to do? Cool it down. What do you guys say?
Heat it up.
Well, if you heat it up, it'll turn into a plasma. If you cool it down, it's a gas. So if you wanted to go with a liquid, what do you think we have to do? Not heat it up. Cool. Go the other way. Cool it down. Is that what you were going to say? Yeah, cool it down. Take more heat out. It turns back into a liquid. And if you wanted to freeze that water, what do you think you have to do to it? Right, and if you put it in a cold place, it'll take more heat out of it, and it'll turn back into a solid. So it's whether you put heat in or take heat out, that changes the state, and that's what I'm going to do for the rest of my time here. Heat things up and cool them down. But as you guys don't want to be here all day watching me do this, we need to do this. Oh, this is giving me problems today. We need to do this quickly. So to do that, I brought along a special chemical. This chemical is called liquid nitrogen. So I want you all to be good scientists, and I want you to make observations. I want you to tell me what you see as I pour this liquid out. Okay? Everyone ready? Ready to look, watch, and tell me what you see? All right. Here's the liquid nitrogen. What color do you think that liquid is? What color do you think it is? I'm sorry? You think it looks like water? Well, that's a good observation. And what color is water? What color do you think it is? Whitish? What did you think? I started blue? Well, that was because I've got blue gloves near it. It's a clear liquid. Do you see anything else? See it? What do you see? Yeah, there's some sort of vapor. Yeah. Anything else? Yeah, it's bubbling away. It's not sitting still here. Does this remind you of anything? Clear liquid, bubbling, putting off some vapor. Does it remind you of anything? What does it remind you of? Boiling water.
Crystal meth.
This looks an awful lot like boiling water. So how many people think this is boiling up here in my hands? How many don't think it's boiling? How many aren't sure? Because that's an okay answer too. Okay, well, when scientists have a question, they try to answer it with an experiment. So let's do an experiment to see if this liquid is boiling. And I happen to have brought a boiling detector. You guys all know what this is, right? What? It's a tea kettle, a teapot, exactly right. Now, if anyone's here can make the sound that water makes when it boils, let me hear you. What does a tea kettle sound like when water's boiling? Yeah, that whistling sound, exactly right. So what I'm going to do is to pour the liquid nitrogen into the tea kettle. What do you think? Sounds like it's boiling to me. So is this hot or cold? Okay, well what I'm going to bring it around. You don't have to do this if you don't want, but if you want, take one finger and quickly tap the bottom to feel the temperature. Okay? If you want to feel, go ahead. Just tap quickly, don't hold your finger there. Tap it quickly. You want to hold your hand there. Okay. So those of you who touched it, was it hot or cold? Cold? We said it was boiling. How can it be cold and boiling at the same time? I'll tell you the secret. It has to do with what does boiling mean? Boiling is the word we use to talk about a liquid turning into a gas. And we're all used to water. Water boils at 212 degrees Fahrenheit, 100 degrees Celsius. You got to put it on a stove to get it to boil. Other matter, other kinds of stuff, boil at other temperatures. And liquid nitrogen is boiling at a cold temperature. Let me show you that this is really boiling. Oh, be quiet. What I'm going to do is put a little bit of liquid nitrogen into the bottom of this bottle. Let's see here, I'm going to get it in there. Okay. So there it is, you can see it. It's bubbling away. Now, if this is really boiling, if it's really a liquid turning into a gas, I should be able to capture that gas. And I'm going to do that with an extremely sophisticated piece of scientific equipment called a balloon. What's happening now? What's happening? The balloon's getting bigger, and why is it getting bigger? Exactly right, the liquid is boiling, turning into gas, and that gas is filling the balloon. I wonder how big this balloon's going to get. Well, I know how big you think it is. You've got your ears covered already. Yeah. Well, while we're waiting to see what happens to this balloon, let's talk about this liquid. Some of you touched it and said it was cold. Anybody want to make a guess at how cold? How cold do you think it is? Medium cold. Okay, well scientists usually like to work with numbers. Is there a number that means medium to you? 5 degrees above or below 0? Be colder if it were below. Below, 5 below. Ooh, that's cold. Any other ideas? How cold do you think it is? It is below 0. Very good, excellent. Well, let me ask you another question. Where's the coldest place on Earth? Antarctica, the South Pole. Coldest temperature ever measured there is minus 129. Well, I guess I really wanted to accentuate that point. I'll come back to that. Let me show you something else first. Remember that liquid we put in there? A lot of it's still there. In fact, practically all of it is still there. And that's because gas, when it's a gas, takes up a lot more space than when it was a liquid or a solid. If I had filled this bottle with liquid nitrogen, I could fill almost 700 bottles with gas that it would turn to. Okay? Now, we were talking about how cold this stuff was. Minus 129 is the coldest temperature ever measured on Earth, in the atmosphere, naturally. This liquid was boiling at minus 320. This is over twice as cold as the coldest place on Earth. Now, does anybody remember what we had to put into a liquid to get it to boil? What? You have to turn it into a gas. You have to put something into the liquid. What? Heat. Exactly right. So where was the heat coming from? I don't see a stove up here. Where was the heat coming from? Any ideas? No? Well, what are you guys all breathing right now? Air! There's air all around us. It's stuff. It's at about 70 degrees. Minus 320, that's almost 400 degrees difference. This was sucking heat right out of the air. That's where the heat was coming from. Okay, so we have seen a liquid turn into a gas. Let's do something a little different. Let's see. Here we go. What state of matter do I have inside this balloon? Plasma, gas, liquid, or solid?
Air.
But what state is it in? Plasma, gas, liquid, or solid?
Gas.
It's gas, and it is an air. Does anybody know what gases make up the air? Does anybody know what we have to breathe in? What do we have to breathe in that's in the air? We breathe in oxygen, and what do we breathe out? What do we breathe out? Do you know? Carbon dioxide, exactly right. And you know what? The oxygen and the carbon dioxide in here make up less than 1/4 of the gases in here. Does anybody know what the other main gas in here is? It's all around you right now. It's makes up the air.
Oxygen.
No, the oxygen is only about 22%. Nitrogen. We've seen it up here as a liquid, but normally it's all around us as a gas. We're breathing it in and breathing it out right now. But I've got a big bucket full of liquid nitrogen up here, and I have my balloon. How many balloons do you think I could fit into my bucket? How many do you think?
5.
Balloon, this size bucket and this size balloon? 5 balloons? Okay, what do you think? 1. Any other ideas? Any others? 1? 5? Okay, well let's see what we can do. Let's see what we can do. Let's see if we can even get the 1 in. So what I'm going to do is I'm going to put the balloon there, my gloves on, since this stuff is cold. And let's see if I can get this balloon stuffed into this bucket. I don't want it popping out, so I can put it in. Oh, that went in pretty easily. Should we try another one? All right. Let's see. Oh, I've got this blue one. Let's see if we can get this blue one in there. Push it down. Okay. There was room for that one. Hey, maybe there's room for a third one. Should we try? Should we try for 3? All right. I've got this clear one. Maybe the color makes a difference. Let's see. Let's see if we can get this clear one. That one went in as well. Think we should try for 4? Let me see. Oh dear. All I've got left is this small one. Let's see if we can get it in. Here's the deal, guys. If I can get this balloon stuffed into this bucket, you have to tell me why. What's going on that would let me get this many balloons stuffed into this bucket? You don't have to tell me until I get the balloon in. Come on, balloon. Get in there. I think it's going. There it goes. What's going on? What do you think's happening? What do you think's happening? What's freezing? The balloon or the air or both? The balloon's freezing. Okay. The gas is coming out of the balloons. That's a good idea. What do you think? The air is coming out of the balloon. How about you? I'm sorry? It's taking up space because of the air, and so well, how's that making it fit into the bucket? Think about it. What do you think's happening? Okay, so as things get colder, they shrink and get. That's an idea. How about you, sir? Oh, the air's coming out, making more room for the bullets. All right, those are all. You've got an idea what you think's happening. What's happening? It's freezing the air. Well, tell you what. Let's take a look and see if we can figure out what's going on. Let me first put all the liquid nitrogen over here so it's all in one place. Makes it easier to take care of. And let me push these down so we really know that all those balloons are really in this bucket. Okay, let's take a look at these balloons. What are they doing now? Yeah, so did the air ever come out of the balloons? No, it didn't. Let's see if we can see anything here. If you look really carefully, you might see some liquid sloshing around in the bottom of this balloon. See? Whoa! What happened was, when we put the balloons in the really, really cold liquid nitrogen, we took so much heat out that the oxygen and the nitrogen as gas turned into liquid oxygen and liquid nitrogen. And that carbon dioxide, it turned into a solid. It turned into dry ice. Solids and liquids take up very little space, nothing to keep the balloons blown up. That's why they were all shriveled. Bring them out in this nice warm room, the heat flows back in, and the solid and liquids turn back into a gas. The stuff, the matter was there all the time, it just changed its state. Okay, so we have seen a liquid turn into a gas turn into a liquid and a solid. Let's do an experiment with a liquid. What would be a really common liquid that we could do a good experiment with? Any ideas? Really common liquid. Water? Good idea. Anybody got any water? Oh, everybody should have their hand in the air. Over half of what we weigh as human beings is due to the water inside our bodies. Maybe I could invite one of you to come up here, take your hand and put your hand into this bucket, and we could see what would happen to the water inside your bodies. Who would like to do this experiment? No, hang on. Because you and anybody else with their hands up are clearly risk takers, although I'm sure the parents all knew that before you guys came. Tell you what, we're going to do this a little differently. We're going to do this the way a scientist would do it, using a model of your hand. This is a latex glove, a rubber glove, and it's filled with water. And it's a lot like your hand. It has a very thin, stretchy coating, just the way your skin is thin and stretchy. And just the way your skin holds all the blood and muscles and bones and everything inside, this is holding all the water inside. So, you all have good imagination, so we are going to pretend that this is your hand, and we're going to put your hand into the liquid nitrogen. Now, that's going to take a minute or two to do what it's going to do. So in the meantime, I want to do another experiment. This, I need somebody who's really strong. Someone who's, are you really strong? All right, come on up here. What's your name? CJ. What do I have in my hand, CJ? A balloon. Now, what state is this? Plasma, gas, liquid, or solid? The balloon. It's a solid. It's holding its shape. Except when I do this to it. What am I doing to this? I'm stretching it because the little bits of matter that make up this balloon, and when I pull on them, they slip past each other, and when I let go, they bounce right back. But CJ here is extremely strong. So CJ, I'm going to put this on the floor, and I want you to break that balloon into 100 pieces by stomping on it hard. Do it again. One more time. Excellent job. Let's see what kind of damage CJ has not done to this. It's all in one piece, CJ, with this balloon. Tell you what, we're going to give you some help, okay? Stay right there. going to take the balloon and I'm going to put it into the liquid nitrogen. Now remember, this is a solid. You take heat out of a solid, it doesn't change its state. It does change its temperature. It becomes a very cold solid. So CJ, are you ready? We're going to do exactly the same thing. I'm going to put this balloon down in front of you and I want you to stomp on it. Are you ready? Okay. Go for it, CJ. Stomp on it hard. Do it again. Do it again. Excellent job. Now I got a mess to clean up. Let's take a look at this, CJ. Look at this thing. It shattered into 100 pieces like a china plate. But CJ, these pieces, they're stretchy. Why did it break? Well, it would have been, that's a good answer, and that made it very, very cold. So cold that those long chains couldn't stretch. So instead of stretching, they cracked. But now that they're back out here in the nice warm room, taking heat from the air, they're back to being very stretchy again. Let's give them a big round of applause, and you, sir, have a souvenir. All right? So, let's take a look at your hand here.
Cool.
Oh, you guys really want to see this? Because I don't want to gross anybody out. You really want to see it? All right. If I can get it out here. This is your hand. What state of matter is this? Plasma, gas, liquid, oh, or solid? It's solid. It's solid ice, and if this had been your hand and you could have withstood the pain of holding it in there, which I don't think you could have, that's exactly what I could do to your fingers. Take them all off, which would have been messy and somewhat painful, which is why I'm glad you didn't do it. But if I leave this out here in the nice warm air, it'll take heat out of the air, and this solid ice, this solid water, will turn back into liquid water. So we have seen the four states of matter: solid, liquid, gas, and plasma. We've gone back and forth between some of them using the nice warm air and the very cold liquid nitrogen. Need to tell you, liquid nitrogen is used for lots of things besides experiments here at Liberty Science Center. Anybody know anybody who ever had a wart, a little growth on their foot or their hand? Some doctors will cure those by taking liquid nitrogen, freezing that little growth, cracking it off, and the rest of the skin will heal fine. Anybody here ever eat frozen food from the supermarkets? Yeah? All those nutritious carrots and peas and Brussels sprouts? Well, they are frozen so they can be transported across the country. Many of them are frozen in liquid nitrogen. One, because it does it fast. You saw how quickly that pan froze. Two, because it's fast, it doesn't make big ice crystals inside the food and break up the inside, so when it's thawed, it still feels really fresh. Anybody here like scary movies? Oh, you like it when the forest is dark and the fog comes rolling out. You know that monster's going to come out from behind the tree. Well, that special effect can be made using liquid nitrogen. So I'm going to end my program with that. All I ask is that everybody stay behind the orange cones, okay? So what I'm going to do is to take a bucket, and into that bucket, I'm going to pour boiling water. Now, the fact that this water has been boiling means that there's going to be a lot of water as a gas around it. And if we can get that gas to change its state, maybe we can have what they have in the movies. Let's see. Oh, stay behind the orange cones, please. Get off the carpet, please, and I'll blow it on you. You step off the carpet, I'll blow it on you. Back, off the carpet, please. There you go. So I have one last question for all of you. Did you have fun? Yeah! Did you learn something? Yeah! Then give yourselves a big round of applause. We did exactly what we said we were going to do. Thank you all very much. I'd be happy for any questions.
It's the predator and prey relationships. Looking at a Gila monster. What are these? Spiders? Scorpions. Oh, there's one. Spiders.
Look at that little thing on the back. Very big. Let's see, look one more. Let me scan it.
Gaboon viper, huh? Where is he? We're hunting viper. And he wants us to... We're supposed to catalog them, right?
Oh, I didn't have.
Do you see him? Oh, I'll be back. So, snakes out to lunch.
How do we catalog just one animal? Just like write everything it says? Leaf-tailed gecko. This is kind of cool.
Catalog them based on diet or range where they're found, or based on some characteristic of them. Did you see him?
Find it.
Okay, so I'm looking at a stick insect. X. Tatomsoma tularatum. Eastern Australia, tropical forest regions, plants, eats mostly eucalyptus. This is the skyscraper exhibit in Liberty Science Center. This is pretty cool, actually. So the kids line up so that they can have a chance to see what it looks like to walk on planks and beams. This is really actually cool.
That's the best thing.
Thing about it is it would really suck to fall off of that thing, even if you have a safety harness on. It's pretty cool. And they have construction crane exhibit. I like they have like a lot of, excuse me, son, sorry, that's all right. They have a lot of exhibits right here. Like they have one of this elevator. So it's like they actually make it a glass elevator so you can actually see through it. This is a really nice museum. So you can see how an elevator works. Yeah, we've seen glass elevators before, but you know, they make it so kids can see it. It's really cool. It's a really nice museum. Wee! Wee! I'm going back down.